Greetings everyone. This is a video about this Honda front power transistor, and this is from my 2007 Honda Pilot. The transistor burned out. If you see part 1, you've seen me do a test to determine that this indeed was faulty, and so this is about me. I'm gonna take it apart and try to test the components and see if I can find out what's wrong. I've done this before with the rear power transistor when it burned out from my rear blower, so I'm reasonably confident that I can probably try to fix it too. There's a reason why I'm doing this in addition, of course, to just wanting to fix it and see what's inside it. There's a potential cost savings. One of these new OEM costs over $90. Like I think I saw an Amazon price for one for like $97. So if I can take it apart, put a little time into it, find the component that might be messed up, because they're very cheap. They're just simple electronic components, transistors, resistors, and capacitors, and then fix it, then they're significantly cheaper. I'm saving potentially a lot of money. I mean, the rear power transistor, it was around $75, $76, and I think I fixed it for a burned out thermal fuse and a burned out capacitor, and that was like $3. So there's potential savings there. Now, it's not for everybody. You have to have the right tools, and you have to know what you're doing, and I oftentimes don't know, but I figure it out, and I'm willing to try it to see. I mean, after all, it's already broken. I can't make it any worse, quoting Ave. So here I am. I'm gonna take it apart. In the car, from part 1, it was sitting in like this, and there was a harness that was going across. The cable for the transistor itself was running in here, and I had to unplug it and so forth. There were 3 bolts. I took them out, and then I got it out after I took the harness out. And remember from the video, I was testing it. So now that I've got it out, there's 3 screws that need to be taken out, and I'll do those real quick, and then we'll go from there. So I've taken the 3 screws out. It just comes apart pretty easily. This is just a cover to protect the transistor itself. So this big metal piece is the heatsink for the transistor. Let's see if I can zoom in a bit here and then focus so you can see it. Hang on. Might not focus. There it is. Okay. So the transistor itself is in here. Then there's the capacitor. There are 3 resistors. There's a thermal fuse here that's hidden in this thermal compound, and the 4 plugs, of course, are right here, and they route around to a variety of spots inside. There's the other one had kind of a circuit board. This one's kind of less of one, so it's kind of a little more crude, honestly, but I guess this is how they do it. So I will continue to take it apart. I think probably what I'm going to have to do is, you can't really see it too well, but in here there is a screw, and that's holding the transistor down to the heatsink, and there's going to be heatsink compound in there. I can't just pull this off if I take these 2 screws off, because it's gonna be held. So I suspect I'll probably pull these 3. I'll desolder these 3 pins first, and then pull it off that way. Unless I can take this apart, I'm gonna mess around a bit, and I'll be back when I figure out how I'm gonna deal with it. All right, I'm back. And I think what I'm gonna do is I'm gonna desolder the 3 pins that are 3 pins of the transistor, and then unscrew it. Unscrew these screws, and then take it off, and then I can unscrew the transistor and pull it out. So that's what I'm going to do. I got my desoldering gun. Hopefully I've got it hot enough here. We'll see. Should be pretty straightforward. I hope to get it out. So far so good. me see if it's free here. Oh yeah, that one's free. Okay, so assuming there's nothing else holding it in place, should be able to pull this screw off. Get it off here. Oh man, long screw. That one's out. And let's see. Get this one out. All right. Now, it should be pretty free. I should just be able to pull it up, and there we go. So there's the transistor. Right here. And of course there's the screw holding it in. This is the bottom. This part is the thermal fuse. And these are all the other pieces. So, it's kind of too bad they have it this way, because normally if there was a circuit board you could trace out where things go. But my guess is still that this is bad, this capacitor. I mean, I don't know it for a fact, but I'd be willing to say that's probably what's bad. They usually go bad. And that's a kind of surprise. That's an electrolytic capacitor, which are just not quite as good as some of the others. Anyway, so now I'm going to go and pull off this. Well, actually, I don't even need to pull off the transistor, honestly, to test it. I am going to go try to find a data sheet on it first. And then from there, should be able to figure out which is 3 pins, what the orientation is. I mean, it's probably gate drain source, or it could be gate drain source. I don't know. And from that point, then I can test it using just standard transistors testing schemes. Then the same thing with this thermal fuse with it disconnected. Or I might pull it out to see. I mean, my guess would be that it's bad, but I don't know that. But that's what we're going to do now. I'll be back. I'm going to take a couple more pieces off, and then I'll show you that. So I took the capacitor out. Here it is, kind of hard to see. It's 0.47 microfarads. So when I test it, and my LCR meter comes back at 415. Now if I switch the nanofarads, which is 0.41 microfarads, but this is a low frequency, so one of the important points is you have to test the frequency. If I test it at 120 hertz, which is probably about what it's going to run, it comes back at 473 nanofarads, which is actually pretty good. That's pretty much where it should be. And even if you give, say, a 10% variance in terms of tolerance level, that's still well within what it should be. So I think the capacitor is actually good. Now I'm not completely sure about that, what they say, but it's the way it is. Now I did dig up the data sheet for the transistor. It's the K2313, which you can see. Let me put this out of the way, which you can see right here, of course. I'm going to go and do some testing on it according to the package. Let's see, you got gate, drain, and source. So I'll be back in a minute once I check that out and get that set up. And to go put my LCR meter up and whatnot. Hang on a second. Alright, I won't show you the transistor test. You can find videos about that. Basically though, you check the gate, drain, and source, and using the diode mode on your multimeter, you test to make sure you first check to see that the gate is closed, and then you open the gate, and you close the gate back, and then you flip it and check that the current going the other way. The diode is there's a voltage drop that's within a certain range. It works. So at this point, it's going to get a little a little out of sorts because I'd expected some things, but nothing, not to worry though. I'll figure it out and find out what's wrong. So now, since I know the transistor is good and the capacitor is testing out, at this point then I'm going to have to go and check the thermal fuse. I think what I'll do with that, that's here. It's just saying it's covered in the stuff, the thermal paste. I'm going to probably desolder it to test it out of circuit and then see what it comes back. It could have just been that this thing overheated, and that's the only component that's gone bad. After that, I may pull some of these leads and test these resistors to see, because there isn't much else. You've only got thermal fuse, capacitor, the transistor, and then these three resistors, and that's it. And if all those are fine at that point, I'm not sure what would be wrong, because I don't see anything else that's off. I don't see anything melted. I don't see any broken connections. Now it could be, or maybe one of these solder joints is bad, and by desoldering and resoldering you can fix it. There's been other electrical components in cars I've seen over the years. There's one that's become pretty famous, the Kelsey Hawkins ABS system, which was very common back, I think 90s. It was ABS for GM cars, so like you find in Corvettes, like my Honda Passport, which is another car I have. It has an ABS, a Kelsey Hawkins, and they're well known to start throwing, it's like a code C1204, something like that. That's probably not the correct code, but what happens is they will start throwing that code, and the reality is there's a solder joint that's slightly broken on the relay, and what you do to fix it, instead of spending potentially up to $1,000 for a new ABS unit, you crack it out, take it out, crack it open, carefully resolder all the joints, put it back together, and that usually fixes the problem. So there could be something like that with this, that even though these joints may seem fine, there might be something wrong with one of them. Or it could be one of these components is just bad. And I don't know, maybe this capacitor, maybe I'll go try to find a data sheet on it. I don't really have much to go on it. It's got the value, 50 volts at 0.47 microfarads. And like I said, it tests fine, and I don't see anything wrong with it. But maybe there is a problem with it, and I'm just not aware of it. So what I may do is try, I'll probably go and try to test all these components again, find a data sheet for this capacitor, and then see if I can isolate what component is bad. I mean, maybe just the thermal fuse is blown and that's the real problem with it. Anyway, I'm going to go and poke around, and when I find something, I'll show you that. Alright, to figure out what the problem is. It's a thermistor. It is burned out completely. It should not be showing this. There should be, on resistance, there should be some, or I don't know if it's thermistor, thermal fuse, I guess, if you will, but it is passing no current, and right now, with it being as cool as it is, it should be passing a pretty good amount of current. The way these work is as they heat up, so like as the device is running and it heats up, they start choking the current, and preventing the components from being damaged. So what you'll see is that the resistance will increase. Well, you should never say this, which is simply that this thing is open. There is no open lead, meaning there is nothing, no connection between the two. If we switch this to continuity, right now, given that it's room temperature and this thing's pretty cool, I shouldn't be seeing, I should have some something going through, and I don't. So it's dead. This is what I need to replace. I actually may have one of these from the last time I worked on the other transistor, so I'll take a look around, and we'll see how this goes. Alright, that's more testing and all the other components. There's not much else left to test. These three resistors, since the circuit's pretty much broken, you can pretty much test them without any concern about messing up the values. So they all test out fine. This is a 1 kilo ohm, and it's almost 1 kilo ohm when I test it. This one's 1.5 kilo ohms, and it comes out fine. This is 10 kilo ohms, and it also comes out fine. So I think at this point, again, the only thing that's burnt out is this thermal fuse or thermistor. I don't know if it's really a thermistor, but It's burned out and needs to be replaced. Transistor test fine, capacitor test fine, so I'm going to put all that back together. If, however, this doesn't work, or if it burns out again, I think the next step I'll do is I'll replace the capacitor and try it again. I mean, honestly, again, this component costs $90. Or I'm sorry, $97 roughly on Amazon. That's brand new. It probably costs more if you buy directly from Honda. So replacing these tiny electrical components, I mean, these things are probably 30-50 cents a piece at tops. They're easy to find on DigiKey or Mauser or other places. So it's trivial for me. I can replace all of this as long as these wires aren't broken, and I'm pretty sure they're not. It's a lot cheaper, and sure, it's a little irritating to do it, but it's significantly cheaper to do this than it is to just buy a whole new part. It's kind of foolish to do that, honestly, for someone like me. For somebody else who doesn't have the time or the patience or the skill, not saying that I have much skill, yeah, it's probably better for them to go do this. But this is where I'm at. I will move forward, and I will bring you along as I move forward. Right now, I'm going to see if I have one of these. I think I do. If I do, I'll solder it in back in this location here. I'll also put the capacitor back, and then once I get all that back together, I'll screw this back on. Screw the transistor back on, put it back on, solder it in, and that should do it. And then I'll hook it up and test it out before I even have to screw it back in, and we'll see if it works. And I'll bring you along for the ride when I get to each stopping point and show you. And as I go along and hit each stopping point, I'll bring you along for the ride and show you where I'm at. Is that they are not the correct values for this application. I need 114 degrees Celsius at passing 2 amps, and these are 134 degrees passing 2 amps, so they won't work. I'll have to order some more, and when I get those in, we'll continue on trying to fix this. Well, a few days later, and I have a bag of thermal fuses. So now we get to go and solder this stuff all back together and put this all back. I've tested all the components, including the capacitor, and I can't find any reason why it burned out. That does bother me, because usually that means there's a problem, and I haven't found it. I'm right now going to just assume that since this car is old, it's just probably old, and that's why it burned out. Last time on the rear one, it was the capacitor, but this capacitor checks out perfectly, and there's nothing visually wrong with it either. So I don't know. But I've ordered some capacitors just in case. I didn't have this particular size and specification for this, and so I've ordered some. So if it burns out again, I'll go and replace the capacitor, because that's usually what ends up being wrong with it in my experience. That said, now I'm going to go and put the new thermal fuse on, and they have the way they come. In this case, mine doesn't have the this insulation around it, so I'm going to put some heat shrink on it and try to simulate it. And of course, I use this as a guide to cut it to the right length. When I'm done with that, I'll bring you guys back. Alright, I've got everything back connected. Screwed this in. I've got the thermal fuse in. I use Kapton tape instead. Probably not the best, but it will work for this purpose, I think. Because the heat shrink just really wasn't working out too well. Probably could use like a liquid electrical tape, but I'm not going to dig that out. The Kapton tape is pretty quick and easy, and I know it'll work. That said, I got to do these 3 pins. I've rescrewed. I put some thermal paste back on where the thermal fuse fits right here, and then put the capacitor back in. Like I said, I'm going to do these 3, the gate drain source for the transistor, and then I'm going to put it all back together. Back in a moment. Alright, transistor is soldered back in, all 3 pins. At this point, I'm going to put everything back together and go test it out and see if everything works. Hopefully it will. And if it does, I'll show you the results of that. Hi everyone, so I tested it out, and failure is always an option, and this failed. So With that said, I came back, took it back open, and the thermal fuse had blown. So I don't know if the thermal fuse was blown before I tested it or after, and something else is wrong. My guess is, I'm hoping at least, that I blew it beforehand, because what I did was, when I soldered it back on, I did leave it on there for a while, and maybe I blew the fuse because it got too hot. What I'm going to do is pull it back off and try another fuse and test it out before I put it on, solder it on, then test it after. And at that point, I hopefully will have a good idea of whether or not I'm the cause, or if it's something going on when I plug it back in. But I'll bring you along when I get to a good point to show you something. Back soon. All right, I'm back. I have put in the another thermal fuse. I was a lot more careful this time with my soldering technique, and then put everything back together. And in fact, before I screwed this cover back on to the heatsink where most of the parts were mounted for the power transistor and all the components, I tested the thermal fuse to make sure it was still good. So I just plugged it in. I've already tried it once, but just to show you that the proof is in the pudding, I'll start the car, and voila, blower is blowing. Let's turn it up a bit, and I got a cold air coming out. So that's about it. Happy with this fix. It's let's see, the thermal fuses cost me about, I think it was around like $5 or something. I got 10 of them. That's also something else I do. Might be a little wasteful, but I do buy more than one, because sometimes you make mistakes, as you saw me make. That's about it, though. Hope this is, if not helpful, at least interesting. And if you like any more of these, as I work on other things or do other things, I'll put them up. So if you like, subscribe, and I hope to see you again. Thanks.